Now, before we get into the demonstration, I want to draw your attention to the table on the screen. This table captures our performance benchmarking results, where we're comparing the old single-threaded processing architecture to the new multi-threaded processing architecture. Now, a couple things that I want to call out here. The first is that the exact same document set was used across both benchmarking results. And in both instances, we used one virtual machine for both the single and multi-threaded processing architectures. However, in the single-threaded processing architecture, you can't have more than one engine instance per machine, therefore because it's single. But in the multi-threaded processing instance, we were able to spawn up 6 engine instances per machine. In other words, in the first set, you're only able to do one document and one job at a time. In the second set, we're able to do 6 documents or 6 jobs at a time. Now, the other thing to mention here is even though our benchmark demo was operated with 6 engine instances in parallel, that number could be higher or lower based on a customer's document set, based on your technical specs, and a couple other variables. You can see that the overall time to process those pages, those 1 million pages, was significantly quicker using the new architecture, totaling just about 1.3 days to process all 1 million documents. Whereas the old single-threaded processing way took about an entire work week to get through all of the documents that were submitted. Now we could go ahead and dive into the demo to see what that looks like in action. In front of you, you're seeing our engine dashboard. And similar to what you saw on that table, what you see here is we only have our one machine that we're using in this demonstration. And what you'll also notice shortly is even though there's only the one machine here, since I have my machine configured to the multi-threaded processing architecture, once I submit a set of documents, you'll see how this spawns up all the engine instances in parallel to start actioning the documents that we send over. So what I'm going to do is I'm just going to go ahead and I'm going to grab a sample of documents here, and I'll go ahead and submit that into our input folder. Now, when I go ahead and refresh this page, you'll see that that one machine was able to spawn up multiple instances in parallel to start actioning those documents. Similarly, if I take a look at our job status table, you'll see that a large majority of those jobs have already been completed successfully. The remainder are still in processing, and the final few documents that aren't yet picked up by the engine are waiting in the ready state. And as soon as another engine instance finishes a job and is ready for a new document, it'll go ahead and grab something that's still in the queue. Now, upon my next refresh, you can see that everything has completed successfully. Now, of course, my demonstration was done with a smaller document set, but once again, if you take a look at the table in front of you, you'll see that the overall results of using the new way versus the old way is significantly stronger. Now, this not only gives us great results from a performance standpoint, but what we aim to do with this architecture is go ahead and reduce your total cost of ownership when it comes to using Transform. In other words, we want you to be able to do more work with less infrastructure as compared to the old way.